Hello students, I'm going to go ahead and visually demonstrate how you would solve these 2% problems, scaffolding off of student understanding of common fractions, and how you would present it with a visual model. So the first problem, the baseball team won 80% of the 25 games it played this year. How many games were lost? First thing that you want to do is change the 80% to a common fraction, which we know is the same as 4/5. Now, of course, you could reduce it to that even if the students didn't have that committed to memory by putting 80 over 100, canceling out your trailing zeros and simplifying the 8/10 to be a 4/5. The important thing is that they get to that place. Why? Because you want to scaffold off their understanding of fractions, which they are very familiar with. Now, so now what they're seeing is that 4/5 of the 25 games were won. So they could draw a visual model, perhaps an area model like a bar, and they could divide that up into fifths. And they could realize, oh, 25 is divisible by fifths. So each of these represent 5 games, each of my partitions. We have won 4/5 of them, which total to 20, meaning we have lost 1/5, which is 5 games. So see how easy that was to solve using that common fraction? This is one excellent way to scaffold off a student understanding not only of common fractions, but also their understanding of some of the typical representations that we use, such as an area model for displaying fractions. Let's move to the second one. In Mr. Carter's class, 20 students, or 66 and 2/3%, were on the honor roll. How many students are in her class? Now, 66 and 2/3 to you might seem like it's not a common fraction or a common percent or fraction change. However, if you put up the common fractions and their decimal and percent equivalencies in the beginning of a class when you're introducing percents and fractions to students, they will quickly realize, oh, this is one. Which one is it? It's part of the thirds family. So 1/3 is 0.3 repeating, or 33, and 1/3%. And then 2/3 is 66 and 2/3%, or 0.6 repeating. So they would realize that 66 and 2/3%, that's the same as saying 6 repeating, which is the same as saying 6/9, which would reduce to 2/3. Okay, so we have 2/3. So if we draw again an area model, and we split this up into thirds, 2/3 of those students, 20 students, were on the honor roll. So in each of these 2/3 here, we would place how many? We would place 10, because we split that 20 in half. Well, if each third consists of 10, then that final amount, which were not on the honor roll, also consists of 10. So altogether, since this entire area bar represents the entire class, there would be 30 students in the class. So again, being able to transform your common fractions and percents to one another is critical for helping students scaffold off what they already know, which is fractions, and then employing the same type of models, area models for instance, to help students visualize what they're solving will help to give them a more concrete understanding.